You have completed almost 4 units. The last remaining of 2 units, and the fifth unit is too small. That is unit number 5 is propagation ethics. It takes hardly 2 hours, 2 hours to complete this unit. It having only 4 contents and the propagation effects. This is the new unit he has mentioned in the last year. The previously it is there for a station, the continuation of a station for another unit, but due to some suggestions given by the authorities, that they have changed the unit from unit number 5 from a station to the propagation effects. What is meant by propagation first? You have heard the name, that is propagation. The propagation of light, the propagation of sound, the propagation of waves. Okay, this is what the propagation, and this effects is going to affect for the environmental condition. That is what the meaning of propagation effects. This propagation effects in this unit they have mentioned a condition of only the environment, that is weather conditions it is going to affect, it is going to detect. Okay, that is propagation of light, propagation of sound, and propagation of waves. Which are the waves we are using in this? The two waves we are using, one is X-ray and gamma rays. These two waves are going to harmful our body, that is very hazardous, very dangerous rays. So these two are present in our station and it is going to have harmful for our health. So we have mentioned the propagation effects, that is X-ray and gamma rays. The propagation effects, the propagation is nothing but the propagation of light, the propagation of sound, and the propagation of waves. It is to be diverted in one or more directions and other parts of the atmosphere. It is going to propagate in one or more direction and other parts of the atmosphere, that is called as propagation. It is going to affect our human beings health, that is called as propagation effects. This he has mentioned only 4 points, that is introduction to propagation effects, atmospheric absorption, cloud attenuation, tropospheric and ionospheric scintillation, and low angle fading, and rain induced attenuation. The 4 points are there. One is atmospheric absorption, cloud attenuation, and third point is tropospheric and ionospheric scintillation and low angle fading, and the last point is rain induced attenuation. Okay, these are the 4 main points we are saying here. That is, what is propagation effects? The atmospheric absorption. The atmospheric absorption is nothing but whatever we are going to send a signal, that signal is going to absorb by this different rays, and these rays is going to affect the particular signal of that signal. That is, the earth is constantly bombarded with electromagnetic radiation. Okay, whatever the sun, that is the radiation we are getting from a sun to our human body, that is always is bombarded with the electromagnetic radiation, that is earth. But the atmosphere protects us from the exposure to higher energy. The two energies are very dangerous. These energy waves is going to include X-ray and the gamma rays. It is going to harmful our human body. That is higher energy waves that can be harmful to the life. That is X-ray and gamma rays. The Earth atmosphere reflects, absorbs, and scatters electromagnetic radiation. What is reflect? Whatever the image you are seeing in the mirror, that is to be reflected like that. Whatever the rays coming from the that is from sun to the Earth station, that is to be reflected back. It is going to absorb and scattered in different directions. That is using the electromagnetic radiation. This has a significant implications to remote sensing, as most radiation detected by passive remote sensor passes through the atmosphere where it interacts with the molecules, particles in the atmosphere. And these all the waves and these all the rays are going to hamper this is going to hamper our molecules and particles and atoms present in the Earth station. That is what the main concept of this is. They have to be safe about these two waves, that is from X-rays and gamma rays. In portions of the electromagnetic spectrum, a significant amount of energy are absorbed by the Earth atmosphere. So if there is a atmosphere is there, we are not getting that much of energy, that much of harmful energy at the Earth station because of this Earth atmosphere. So atmosphere is going to protect our health. That is, atmosphere is going to protect our health. So he has considered mainly the protective is of atmosphere, that is propagation of light, propagation of sound, and propagation of waves. It is going to protect our health because of only the Earth atmosphere, with a very little of the energy reaching the Earth surface. Whenever the sun rays are coming to the Earth station, the last highly rays are scattered in the Earth atmosphere, and the limited rays are reaching at the Earth atmosphere. So we are not going to hamper our health. And all radiations detected by remote sensors passes through the atmosphere for some distance. This distance is known as the path length. Path length is nothing but if the distance is more from Earth station to the satellite, if the distance is more from Earth station to the space. So space, if the distance is more, we are going to hamper less number of signals at the Earth station. The path length can vary. It can be vary, of course. We have a low Earth orbit, medium Earth orbit, and the high Earth orbit. It may vary. It could be a short path, that is handheld cameras are there for considering all this harmful X-rays and gamma rays of the signal, and a very long path, that is space-based sensors. They are going to install some of the sensors in between this low Earth orbit, medium, and the high Earth orbit. These sensors is going to detect a particular ray, which ray is harmful, which ray is going to hamper the Earth station. They are going to maintain the different sensors to detect the particular signal. And what is meant by absorption? That is important. What is meant by absorption? The absorption is nothing but what? Absorption is the process by which incident radiation energy is retained by the substances. What are the substances present at the Earth station? That is the atoms, molecules, and some of the electrons. That is absorbed by the some of the rays. That is substances. That is absorption of energy. In this case, the substance is the atmosphere. In the atmosphere itself, they are going to present atoms, molecules, and the electrons. When the atmosphere absorbs energy, the result is an irreversible transformation of radiation into another form of energy. So whatever the signal we are getting from a sun and from the space, it is going to convert the other form of energy to protect the health or the atmosphere condition. This energy is transferred according to the nature of the medium doing the absorbing. The absorbing medium can also be do much more. Whatever the absorption of electrons, holes, and atoms are doing, that thing also doing by the Earth atmosphere. That is the meaning of this. The medium is nothing but your Earth station. The medium is nothing but your atmosphere, Earth atmosphere. The medium will only absorb a portion of the total energy. The Earth atmosphere, that is the atmosphere, is going to absorb only the total energy, and the remaining energy will be reached to the Earth station. That is, the other energy will either be reflected, refracted, and scattered. These three, reflected, refracted, and scattered energy, will reach to our Earth station. The energy absorbed can also be transmitted back into the other parts of the atmosphere. Whatever the absorbed energy, we are going to send it for the signal and for the human beings of the life. The atmosphere, due to many of the different gases, particles contain therein absorbs and transmit many different wavelengths of electromagnetic radiation. Due to this electromagnetic radiation, harmful effects, though they are going to present a particular particles in that particular signal. So absorption is mainly caused by the three different atmospheric gases. The contrary to popular belief, water vapor causes the most absorption. Whenever there is a summer season, the water vapor is more, it is going to absorb more energy at the space. The followed by the carbon dioxide and then ozone. In the at this time of summer, there is a pollution is more, so it is going to absorb more number of energy, that is using the carbon dioxide and the ozone. And they have shown this in this picture, that is water vapor, carbon dioxide and ozone, how it is going to affect ozone. That is, see the waveform, that is H2O. H2O is nothing but your water vapor, and carbon dioxide, that is CO2, and the ozone is, that is simply constant. So water vapor is having a more amount of absorption. Okay, and atmosphere absorption of electromagnetic radiation helps the earth in two main ways. Atmospheric absorption of electromagnetic radiation. Electromagnetic radiations are nothing but your X-ray and gamma rays. Help into that is first absorption helps people by preventing high energy radiation from reaching the surface. Whatever the X-ray and gamma rays are reaching at the Earth station, which limits our exposure to harmful the radiation. These are going to control the energy of harmful energy while reaching the Earth station. Next point is the atmosphere absorbs most of the radiation from the ultraviolet region to the X-ray region, and which is going to absorb the two regions. One is your region, that is ultraviolet region, the X-ray. And the second way is which one? The second way in which absorption helps the earth is an heat source for it. There is a heat, it is going to absorb more amount of energy. If one way, hello, Vaishnavi, Vaishnavi, mute yourself. The second way in which the absorption helps the earth is an heat source for it. If one were to take a vertical cross section of the entire atmosphere, one would note that the temperature generally increases with the height. How the height of the space is going to increase, you have to maintain, how you have to mount a particular antenna in different directions. That is what you have to save a particular harmful energy which is reached at the atmosphere. This increase in temperature is caused by the increase in the absorption. How the temperature is goes on increasing at the height is increases, it is going to increase the absorption of the particular energy. It is going to increase the absorption of particular energy of electromagnetic radiation with height due to higher concentration of high energy. If height is goes on increases and absorption is also increases. If height is increases, absorption is increases, and it is going to use a huge amount of energy with a wavelength. Absorbing gases present at higher atmosphere levels. It is going to affect the most of the atoms, molecules, and electrons. So it is going to damage through the high energy of waves. There are three possible conditions you have seen. One is water vapor, it is going to absorb more amount of energy, and second is your carbon dioxide, and the third is your ozone. The combination of these three, water vapor and carbon dioxide and ozone, the combination of the three waveform, the signal and the total vapors and the absorption of the signal is getting, that is the first one. Okay, that is what the concept of this atmosphere absorption. The water vapor is very strong absorber in 5.5 to 7 micrometer range, that is greater than 27 micrometer. Note that water vapor in the atmosphere is also variable in time and space. How the seasons are going to change, the water vapor may decrease or increase depending on the space. This means absorption rates may vary depending on the location and the time of day and the year. Location also depends on the vaporing, the absorption of water due to high energy, and it is going to have a time, that is a day and a year. In the year, we are going to divide the three, that is winter, rainy and summer. Based on this, it is going to differ a particular energy. Next, ozone, next carbon dioxide, primarily absorbs in the mid and far. Okay, that is in the summer season, it is going to affect more to the health of the human beings. That is high energy is there. That is infrared portion of the spectrum. The air census is going to affect a particular earth station. So that is carbon dioxide. And the ozone O3 absorbs strongly in the ultraviolet portion of the spectrum. Very short wavelength, that is ozone. It is not having that much of energy, very less amount of energy it is having at the ozone layer. So it is responsible for protecting us from the damaging radiation that causes skin cancer. If there is ultraviolet radiations are very high, but it is projected on ozone layer, but it is, if it is, we can't control it, we'll get a skin cancer through this high energy, that is through the ozone layer. This is what the first point of propagation effects. In this propagation effects, what you were saying, you are going to have electromagnetic radiations, and these electromagnetic radiations is going to have two waves, the very hazardous, very dangerous waves. One is X-ray and one is gamma ray. You have to protect this from the waves, and these two waves you have to protect it only through the particles of atoms, molecules and the electrons. This is going to take care of our health, and this is to be spread in the earth atmosphere, and earth atmosphere has to scatter. That is to be done the three parts. One is reflected, refracted and the scattered in different directions. So if it is scattered and reflected in different directions, so we are going to protect from the these waves at the human beings. So this is what the first point, the concept of atmospheric absorption. This is the common point. The second point is cloud attenuation. What is attenuation? Attenuation of signal, attenuated, signal scattered, and the signal will diverted. That is the meaning of cloud attenuation. In the transmission of electromagnetic signals, attenuation caused by absorption and scattering by water or ice particles in the cloud. The cloud is present at the space. It is mainly affected only because of this absorption of energy, the absorption of water at the water, that is from the ice particles in the cloud. That is, there is a note he has written here. The amount of cloud attenuation depends on many factors. It is to be depends on many factors. Which are those factors? The first is a density, particle size, and the turbulence of the cloud. What is turbulence? And steady movement of air and water. If there is not a stable movement of the air and the water is there, so it is going to hamper a particular attenuation of the signal, attenuation of the particular energy. And the transmission path length in the cloud. The path length, if it is the absorption is very high, that the height is very large, so it is going to affect the path length. Path length is nothing but what a distance. The distance is increases, it is going to have a high intensity. So that is what the cloud attenuation is, mainly depends on the absorption of the signal and scattering of by water and the ice particles. Okay, this mainly depends on, first is the density, and second is your particle size, and third is an unsteady movement of air and water. And the next is The attenuation due to clouds at frequency above 10 GHz. How this cloud attenuation is happens, the frequency band is going to maintain. If the frequency band, if it is more than 10 gigahertz, the cloud attenuation is there. That is to be attenuation of the signal by the water and the ice particles is going to happen. The study of cloud properties is increasingly important in the context of climate research of troposphere. At the cloud space, we are going to have two things. One is troposphere, one is ionosphere. Okay, and this cloud attenuation is only depends on your troposphere. It is the study of cloud properties is increasingly important in the context of cloud increases in the troposphere. At Ku and Ka frequencies, we are having a three frequency. One is C band, one is Ku band, and one is Ka band. And this cloud attenuation is going to hamper only in the Ku and Ka frequency bands. That is from the higher Earth orbit. Higher Earth orbit, we are using this Ku and Ka frequency bands. Radio signals are expected to experience losses due to cloud at any time of the day. Okay, at any time they are going to observe the signal, so it is going to affect a particular losses. It is going to affect a particular losses of the signal if there is a cloud condition is there. Depending on the type of season and the climate of the location. Depending on the season, it is going to affect a particular signal when it is reaches to the particular Earth station. Although the effect of rain on the radio is more than the effect due to clouds. So whatever the signal we are getting from the satellite, okay, your TV signal, it is going to affect when the weather is changing. When there is a rain, you will getting the signal, proper signal. When there is a changes in the cloud, in the weather condition, there is a loss in the signal. We are going to lose a particular signal. That is what the effect. The cloud is going to affect the most of the signals present at the station. The rain is not going to affect that much, but clouds are going to affect a particular signal at more than rain attenuation. The occurrence of cloud is always more than the rain. The cloud is going to affect the more signal than the rain. That is, he has written, the occurrence of cloud is always more than the rain. The liquid water content, that is LWC of clouds, is a physical cause by cloud attenuation. It is going to have the particular point, that is liquid water content. It is going to affect our cloud attenuation. Cloud impairment increases the rate of attenuation. Impairment is nothing but there is a same in the signal, that is particular cloud, the water vapors or the ice. These are the impairments. They increase the rate of attenuation of signal in the satellite communication links, thereby resulting to the poor services. What I have told previously, or TV signal, there is some changes in weather conditions, you are not receiving the signal. But if there is a rain, you are getting the signal at the Earth station. If there is a changes in the cloud or the weather condition, it is going to affect a particular signal. We are going to have a poor services. The majority of these cloud impairments are due to rainfall, high relative humidity. Humidity is very important for accessing the signal, and climate conditions. These are the three main impairments we are using. That is, one is rainfall. If it is rain is there, we are not accessing the signal. If it is humidity is there, we are not going to have a poor signal, and other climate conditions. And it is therefore necessary to have a good predictions of these impairments, which will subsequently help in the design, location, and the deployment of satellite systems in the tropical region around the world. So whatever you are implementing a particular satellite, we don't know at what time when the rains will come, what the cloud is going to happen. So most of the things we are going to have a particular loss of the signal at the time of rainy season. In the remaining 2 seasons, we are not getting any hamper in the signal. There are 2 essential facts that constitute the appearance of cloud. Which are those appearances? That is, one is stability of atmosphere in the cloud vicinity. Stability is not there in the atmosphere. It may vary, and it will not be a stability. That is always unstable. Okay. So increasing development of participation within the cloud. Okay. If you want to, you have a appearance in the cloud, increasing, you have to increase the number of participants, and that is perception in the cloud. The mechanism of which clouds form involves a parts of the atmosphere being cooled below its dew point. If it is there is a dew point is very cooled, so due to this excess water vapor and the ice particles, so that is very harmful for to access the signals. It follows that there can be no condensation of water vapor in clean air unless one of these two conditions. Which are these two conditions? First is water vapor becomes extremely supersaturated with a relative humidity of more than few hundred percentage. When there is a rain, the cloud is going to have a relative humidity of percentage with the droplets that is of 0.001 micrometer. The relative humidity reached to the 340%. Yes, given. That is already research has taken place in this. They are going to have a humidity with a 340%. We get in contact with the existing water or the surface suspended in the air. Ice particles and with existing water vapors is to be suspended in air. There are 10 basic cloud types spanning 3 categories. One is low, medium, and high. Okay, we have seen the number of satellites have to be launched in different Earth station. One is low Earth orbit, medium, and the high Earth orbit. So the same thing, they are going to have the 3 types, the 3 categories. One is low cloud attenuation, medium cloud attenuation, and high cloud attenuation. These categories are based on the altitude of the cloud. What is the height of the particular cloud? That is base bottom from the ground. The 3 categories: low clouds, medium clouds, and the high clouds. What is the meaning of this low cloud? The cloud that have a base below 2000 meters, that is 7,000 feet from the surface. 7,000 feet from the Earth surface, contain high amount of water droplets. It is going to low Earth orbit, that is low clouds. It is having a high amount of water droplets. That is, cloud types in this category includes cumulus. One is cumulus, cumulonimbus, stratus, stratocumulus. These are the 4 the main clouds. The cloud different categories it is going to have. One is cumulus, cumulonimbus, stratus, and stratocumulus. These are the 4 different categories they are going to have the low clouds. And the medium clouds that have a base range that is 2,700 7,000 meters more than a low cloud, that is 7,000 to 17,000 feet. These also contain water droplets, and these water droplets as are named as altocumulus, altotracis, and nimbostratus. These are the three main water droplets it is having in the medium cloud. One is altocumulus, altostratus, and nimbostratus. And the last is your high clouds, usually at present at your space, usually made up of ice crystals. It is mainly made up of your ice crystals. Their base range between 5,500 to 14,000 meters, or the feet he has considered as 17,000 to 35,000 feet. And the main categories present in high clouds are cirrus, cirrostratus, and cirrocumulus. How we are going to differ in low Earth orbit, high Earth orbit, medium Earth orbit, and the high Earth orbit. The same thing we are going to divide in the cloud also, that is low, medium, and high. And he has mentioned the particular height of a particular cloud, that is your low cloud, medium cloud, and high cloud. This is what the concept of your cloud attenuation. And the third point we'll see tomorrow, that is troposphere and ionosphere scintillation and low angle fading, and that completes your unit number 5. Then in the lecture Saturday, I'll take 15 to 20 minutes of last minute and be ready for a remaining tutorial point. On Saturday, be ready for a tutorial to give the seminar. That is important. I will take only 15 to 20 minutes and will complete this unit. And after 15 to 20 minutes, remaining you have to give the your seminars or as a tutorial. Keep in mind. I think we have completed 2 points. That is, one is atmospheric absorption and second is cloud attenuation. And tomorrow's in the next lecture we have to see, we can see the troposphere ionospheric scintillation and low angle fading, and the last point is your rain induced attenuation. Okay, what you are seeing in this atmospheric absorption, I will explain you again. That is atmospheric absorption number 2. Where in the atmospheric absorption mainly because of your electromagnetic radiations, and electromagnetic radiations is going to hamper through the two waves, one is X-ray and one is gamma rays. And if the distance of the from a station from the space is distance is high, we are going to have a maximum attenuation absorption of the signal, and this signal is going to hamper the three different types. One is reflected, refracted and scattered in this portion, and it is going to hamper three basic concepts. One is water vapor, one second is carbon dioxide, and one is ozone. Okay, the ozone layer is having a, we are going to cause a skin cancer through the ozone layer, and the carbon dioxide is going to mainly hamper in the summer side, and the water vapor is going to maximum water vapor in the absorption. Cloud attenuation, this cloud attenuation is going to hamper only because of your water and the ice particles only. Okay, and this ice particles is going to divide mainly for three categories. One is low cloud, one is medium cloud, and one is high clouds. Okay, and they are again divided these clouds into the different categories. They are given the name for these categories as cumulus, cumulonimbus, stratus, and stratocumulus for low cloud, and for medium cloud, altocumulus, altostratus, and cumulostratus, and for high cloud, cirrus, cirrostratus, and stratocumulus. Okay, these are 2 points, and remaining 2 points we'll see in the next class. And follow